We want to see whether y equals x squared times e to negative 5 over x cubed has an oblique asymptote. So an oblique asymptote is always going to be linear. So when we're taking the limit as x approaches positive infinity of our function, so we'll call that f of x over x, that's going to equal a, where y equals ax plus b is going to be the formula, the equation for the oblique asymptote. And you have to both do positive and negative infinity. So on one hand you do positive infinity, the other hand you do negative infinity. So that's going to be your other oblique asymptote. So let's look at that. Right now we have x squared e to the negative 5 over x cubed all over x. So that's going to be x e to negative 5 over x cubed, which I can also rewrite as just x over e to the 5 over x cubed. And this is a good way to do this without doing anything complicated, is to think of it logically. What happens as x goes to infinity? Well, x goes to infinity. So this goes to infinity. What happens to the bottom here? Well, x cubed goes to infinity. 5 over x cubed goes to 0. And so e to the 0, that's going to go to 1. So you basically have infinity over 1. So this thing is going to go to infinity. So what that means here is that a is infinity. Well, that doesn't make sense, okay, because infinity is not a number, so that can't happen. And so if you let x go to positive or to negative infinity, basically you have the same situation, except now the top goes to negative infinity and the bottom, well, x cubed is going to negative infinity. 5 over negative infinity goes to 0. So e to the 0 goes to 1. So this is going to negative infinity. And so we're saying a is negative infinity. That makes no sense. So clearly, this does not have an oblique asymptote. Now, to solve for b, what we do is we take the limit as x approaches either positive or negative infinity, take our function and subtract it by ax. Well, we said a is infinity, so you're taking a function, subtracting by infinity. That doesn't work. So clearly it's not going to have an oblique asymptote. Also keep in mind that this is a rational function. So if we're just looking at x, x squared, so let me write that out, x squared over e to the 5 over x cubed, this is a rational function, and we know it has an oblique asymptote when the degree of the top is exactly 1 greater than the degree of the bottom, which, to be quite honest, we don't know what degree the bottom is. So the bottom does not have degree 1. So clearly there's no oblique asymptote.